Assalamualaikum warahmatullahi wabarakatuh. Okay, so in this video, we will go through for the example on heat equation. Heat equation for case A. Okay, case A, where both ends are kept at temperature 0 degrees C. Okay, the question. A rod whose surface is insulated and has a length of 3 units. Okay, length of 3 units. You should know by now that L is equal to 3. And the temperature distribution in the rod is given by, this is the standard equation for heat equation, which is del U del T is UT equal to K USX to del squared U del S squared. So by right, the value for K is equal to 2 then. Okay. Next, if its ends are kept at temperature 0 units, okay, it give away which case that we're gonna do. So temperature 0 unit, automatic, you know, this is case A. When it is case A, means the first boundary condition is when U0T equal to 0. And the next boundary condition is ULT. Since L is equal to 3, so U3T is equal to 0 then. Next, the initial temperature is 25 degrees C, means here Fx is equal to 25 degrees C. Okay, Fx, okay, rather than written as Fx, it's better for you to actually write it like this. Okay, Ux naught. Okay, that means initial temperature, the T should be equal to 0. Okay, Ux naught is equal to 25 degrees C. Or you can leave it as 25 only. Okay, because we gonna omit the unit then. Okay, and next, the question demands us to find the temperature at position X. By right here, find the temperature at position X at time T. The temperature itself refers to UXT. Okay, so let's start. The initial boundary value problem is this one. Where X between 0 to 3 and T is greater than or equal to 0. These are the infos that you need to extract from this one paragraph. Okay, it has been summarized here. The things that I've written here and there is actually has been summarized here. Okay, subject to the boundary conditions U0T equal to U3T equal to 0C, I've written it there. And then initial condition US naught equal to 25. Okay, the first thing that you need to do is you need to let UXT is equal to S of X, T of T. Okay, this is the first thing that you need to do. Okay, and then UTX of T is equal to S of X T prime T. And UXX is equal to X double prime X T of T. Okay, that means here we differentiate U with respect to T, where X, the function X here are held as constant. And this one, we differentiate U with respect to X twice. Okay, because XX, okay. And then we held the T, function T, as constant. Okay, partial derivative. And we substitute these two terms, okay, in the heat equation here. Ut equal to 2USX. Okay, which means we have X of X T prime T equal to 2X double prime X T of T, and can be written as this. Okay, X double prime X over SX. Okay, remember the constant should be with T, so T prime T equal to 2TT, and this one should be written as equal to negative lambda squared, because this is what will satisfy the boundary conditions. Okay, so it leads to the two ODEs, which is the first one, this S double prime X plus lambda squared, because this one here, let me write it here, S double prime over X is equal to negative lambda squared. Okay, so X double prime is equal to negative lambda squared X. Okay, we bring this term to the left, therefore we have this one. Okay, and this part is actually like this, T prime T over 2T of T is equal to negative lambda squared which means it can be rewritten as t prime t equal to negative 2 lambda squared t of t. We bring this term to the right, it will be this one. Okay, which implies the auxiliary and characteristic equation. Okay, where we substitute s over prime equal to m squared. Okay, m squared plus lambda squared, and okay, we have here m equal to plus minus lambda I. Okay, why lambda I? Because this is imaginary actually. I represents the imaginary part. Okay, so here m plus 2 lambda squared equal to 0, where m is equal to negative 2 lambda squared. Okay, so next, therefore the solutions are as such: x of x equal to a1 cos lambda x plus a2 sin lambda x, and t of t is equal to b1, or you can also write it as b. Okay, exponent negative 2 lambda squared t. Okay, refer to the value of m here. Okay, it will be here negative 2 lambda squared. Okay, this one, it is actually the cases for the second differential equation, second order differential equation problem. Okay, and the temperature of the wire would be UST equal to S of X times T of T, which is A1 cos lambda X plus A2 sin lambda X multiplied with B1 exponent negative 2 lambda squared T. Okay, next. Okay, we will apply the boundary conditions. Okay, this is the first condition. Okay, condition 1. Okay, given that U0T is equal to U3T equal to 0. So the first condition that we're going to consider is U0T equal to 0. Okay, since U0T equal to 0, that means X0 T of T equal to 0. T of T does not equal to 0 for some arbitrary T. That's why X0 equal to 0. Okay, and here S of X is equal to this one. So automatically X0 is equal to this. Okay, I would prefer it if you write it like this. X0 equal to A1 cos 0 plus A2 sin 0, which means here you have A1. Okay, A1 plus 0 like this. Okay, A1 plus 0, and then therefore A1 equal to 0. Hence, x of x is just equal to A2 sin lambda x. Next, the second condition is U3T, because ULT, okay, U3T equal to 0. Okay, which means x3 times T of T equal to 0. Okay, this is the value of x, okay. And then T of T does not equal to 0 for some arbitrary T. Therefore, x of 3 equal to 0. And here, x of x is A2 sin lambda x. That means x3 is equal to A2 sin 3 lambda. Okay, it is equal to 0. If A2 equal to 0, then the solution is trivial. Or you can also return it like this. Okay, A2 does not equal to 0. Okay, and then sin 3 lambda is equal to 0, which means 3 lambda equal to n pi. You may add this another line so that you will understand it much clearer. Why we equal to sin n pi? Since sin 3 lambda is equal to sin n pi, so 3 lambda is equal to n pi. So lambda is equal to n pi over 3 for n equal to 1, 2 until infinite. Okay, note that n equal to 0 is not included, because if n equal to 0, then lambda equal to 0, which lead to a trivial solution. That means we're not going to have a solution for u. Okay, therefore for n equal to 1, 2 until infinity, this is our s of n, and this is the t of n. Okay, that means we just rewrite this s of x, but you need to add n. Okay, and then u of n as t is equal to as n x times t of n t. Okay, it will become this one, and can be simplified into this term. Okay, in the previous video, it's written as c, right? So it doesn't matter. If you want to use capital letter A, it's also fine. Okay, but the important thing is it should be another new constant. Okay, so an here, where an is equal to an times bn here. And then remember, write the exponent first, then only the trigonometry. This one you should be careful. It is actually negative 2 over 9 n squared pi squared t. Okay, the negative actually has been combined with the over the straight line. Okay, using superposition principle, therefore uxt is equal to summation n from 1 to infinity a of n exponent negative 2 over 9 n squared pi squared t sine n pi x over 3. Okay, and then by using the initial conditions that we have earlier, which is u as not equal to 25, we can determine the value for an. Okay, u as not, okay, we substitute t equal to 0. Here we will have actually 0 because exponent negative 2 over 9 n squared pi squared times 0 is equal to exponent 0, which is equal to 1. So we are left with this summation only. Summation n from 1 to infinity a of n sine n pi x over 3, which is a representative of the Fourier sine series. And thus, a of n equal to 2 over L integrate 0 to L fx sine n pi x over L with respect to x. Here it will be a of n equal to 2 over 3. Why 3? Because L equal to 3. Okay, integrate 0 to 3. Fx is 25. Okay, so 25 gonna be here. Sine n pi x over 3 then. Just simply refer to here. Or actually you substitute L equal to 3. Okay, integrate with respect to x. Integrate this function, it will be 50 over 3, negative 3 over n pi. 50 because 2 times 25, both are constant, so it can be multiplied. Okay, 50 over 3 times negative 3 over n pi, because we integrate sine, it will be negative cos. Okay, and then this one should be 1 over a. A is n pi over 3. So negative 3 over n pi cos n pi x over 3 from 0 to 3. Substitute the value 0. Substitute the value of upper boundary minus the substitution of the lower boundary. Okay, you will have cos n pi minus 1 here. Okay, to make it clearer, it is actually like this at first. 50 over 3. Okay, open the bracket. Negative 3 over n pi cos n pi. Okay, minus negative 3 over n pi cos 0. So this one is equal to 1. Okay, thus we have this one. Okay, because negative 3 over n pi can be factorized to the front, we have negative 50 over n pi. And this is the final answer then. You can leave it as such, but if you prefer for the constant that has been factorized to be positive, you can rewrite it as such. Okay, so therefore here uxt is equal to summation n from 1 to infinity. Substitute an here. So an is 50 over n pi, 1 minus cos n pi. Rewrite the exponent because this is the function for uxt, right? So you need to rewrite the exponent and also sine n pi x over 3. That's it for case A. Okay, hopefully you can grasp major understanding on how to solve case A for heat equation. Thank you. Assalamualaikum.